Okay, so we're going to find the inverse of this function. So our first step is to change that f of x to a y, not for any reason other than it's kind of easier to work with. Okay, now I've shown you before, this is review, we've switched the x and the y. I'm not going to do that right now. And there's reasons why, but I just don't feel like it. What I want to do is solve for x. Okay, so I want to end up with x equals something in terms of y. So I'm going to do some things. I may not be clear where I'm going, but I know what I have to do. I'm going to multiply both sides by x minus 2. So that gives me x minus, whoops, look at error. Gives me x minus 2 times y equals negative x minus 1. Okay. Then I want to isolate x. That's my goal, is to get x equals. So I'm going to distribute xy minus 2y equals negative x minus 1. And now my goal, remember, is to isolate x. So I want to bring all the x's to one side. So I'm going to add this negative x to one side, so plus x. And then I'm also going to add 2y to move that to the other side. So I have xy plus x equals negative 1, that's left over from here, plus 2y. Okay. Now over on this left side here, what I can do is factor out an x. So I have x times y plus 1, and that's kind of the trick here with these kinds of problems. Negative 1 plus 2y, and then I'm going to divide. So I get x equals negative 1 plus 2y over y plus 1. Okay? Now the thing to know is that this expression here and this expression here are the same expression, right? They represent a relationship between x and y. Here, if I know x, I can find y. Here, if I know y, I can find x. And if I reverse it and make it a new function, I've got the inverse. So I'm going to write the inverse a little bit differently. I'm going to write f inverse of x. That's our maybe new notation. Okay, that little negative 1 is not an exponent. It just means the inverse function of f. And then, since I've chosen to use x as my variable here, I'm going to use x as my variable here. Okay, so that's the relationship. These two, this and that, are inverse functions. And let's just check out an example. I'm running out of colors. Purple. Okay, suppose I tried, let's say, f of 3 here. F of 3 here is going to be negative 3 minus 1 over 3 minus 2, which gives me a negative 4 over 1, which is negative 4. And then if I try f inverse of negative 4, in theory, I should get back to 3. Okay, an input of 3 is going to give me negative 4. An input of negative 4 here will give me a 3. So negative 4, so I have negative 1 plus negative 8. If I plug in negative 4 for x, and then I have negative 4 plus 1. So I have negative 9 over negative 3, which is 3. Okay, so that's an example of 1 point that worked. I'd need to show that for all points, and I'll show you how to do that in the next video.